Hi Pre-Algebra Muffins. This video is going to go all over how to graph using slope-intercept form. And so I'm going to do a bunch of these examples with you. We're going to do this again when I return for my trip as well, but I wanted to make sure that when you're watching this that you're paying really close attention and that you're staying focused, because if not, the questions underneath the video are going to be challenging. Okay. All right, so we talked a lot about slope last week. Slope, remember, rise over run. The letter M stands for slope, change of y over change of x, all of those things. And so today we're going to be graphing using that slope. So we're actually going to go up and over. But we're also going to be using something called the y-intercept. And so our line, we're going to get the whole equations of our line that include both the slope and also the y-intercept. So we're going to go ahead and get started. This is our slope. So when you look at an equation, when y is by itself, the slope, or how much the rate of change is always connected to the variable x. And so here's our slope. And when we think of slope, we want to think of rise over run, okay? Or you can also think of whatever number is in the numerator, that's going to tell me to go up if the number is positive, down if it's negative, and our denominator is always going to move to the right for initially. Really, you can kind of put the negative in the denominator so you can actually move left, but for now, we're just going to stick to the numerator and then use some patterns to go backwards. And the second number that is not connected to the x is the b, and that's the letter that we use to talk about the y-intercept, and this is where we start on the y-axis. And so our first point we always put down is whatever is that number that is not connected to the x. Okay, so we're going to do that one first, and we're going to graph a bunch of these. They don't take very long to graph. Before we would make a lot of tables and plot points, but this is a little bit quicker of a method on that. So the first thing I'm going to do is I'm going to put my y-intercept on the graph. So it says it's +2, so that means on the y-axis I'm going to go to where it says 2, which is right there. I'm going to put a dot. And my slope says, I'll just make it in pink. It says we're going to go up 1, our rise is 1, and we're going to move to the right 3. And so I'm just going to count the grid. From the point I just put down, I'm going to go up 1, and then to the right 3. 1, 2, 3. And that's going to be my next point. And then I'm going to continue that pattern. I'm going to go up 1 to the right 3. And that's going to be where your next point is. I guess I could just leave it like that. See, up 1, over 1, 2, 3. And we could also go down and left to continue the pattern. It kind of looks like stairs, down and left. And so once you get a good amount of points on there, you can connect them. It is a line, which means it goes on forever. You could continue that pattern. I mean, that's kind of jagged there at the end, but that's okay. It would continue the pattern indefinitely, so we could continue that pattern forever. And really any ratio of 1/3. We could go up 3 over 9. We could go up 2 over 6. Any ratio of 1 to 3. Okay, let's do this one here. Same thing. We're going to start, remember, with this point. So -4. It is a minus, so we're going to start at -4 on the y-axis. That's going to be my first point. And you'll notice that 2 is not a fraction. But we can always write our whole numbers as fractions, so we just write the number over 1. So we're going to go up 2 to the right 1. So we're going to count 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. And then you can also go down and left. Look like that. So the slope, again, gives us our pattern. And when you're working on these, if you need to come back to this video to rewatch some of this stuff because you're kind of stuck, that's totally fine. Okay, so then for this one, we're going to start on the y-axis at +1. Now, you'll notice that this is a -3/4, and so we want a nice negative, like Slope Dude said. So all of these other ones, they were going uphill, but this one we want it to go down. And the way we get it to go down is we move down 3, but we still move to the right 4. And so that'll create a line that's going to go downhill. So we're going to count 1, 2, 3 to the right 4. 1, 2, 3, 4. And then we'll do it again. Down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. And then we can also go up and left. 1, 2, 3, 1, 2, 3, 4. So we go up and left, we kind of put the negative in the denominator. So this one will be going up and left, but usually we put the negative with the numerator, so we go down, but the 4 is positive, so we move to the right. So it doesn't really matter the direction, but you don't want to do a double negative, because if you go down and you go left, you actually create a positive slope. It's weird, because you'll actually go down left, it'll actually go uphill, so it's like a double reverse. All right, once you get enough points on there, you can connect them. Okay, we'll do a few more. So this one, again, we're going to start at -2. Always start on the y-axis. There it is. And we're going to write -3 over 1. So we're going to go down 3 to the right 1. So 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And then it looks like that. I mean, ish. Your lines are probably better than mine. Okay, this one's a little bit unique because there is no extra number like the -2. So if you think about it, the number we could add to this that would not change the expression would be 0. So if I start at the origin, if there is no y-intercept, and then we're just going to go up 1 over 2. Or you can go down and left to get that double negative, and then it goes right like that. Maybe. Well, close enough. And so again, this one's going down here. It's a nice negative. That one's going downhill. This one's going uphill on a positive slope, uphill on a positive slope as well. And our last one, we're going to start at 5. And then we are going to, you'll notice that there's no number to the left of x. That just means the number is 1. Remember, there's always a hidden 1. X is the same thing as 1x. So we can always write that 1 in, and then we're going to write it as a fraction. So we're going to go up 1 over 1. So up 1 over 1. Up 1 over 1, up 1 over 1. It's not a very steep line. There we go.